Hi guys, I am Divyang from IGCSE on Fingertips. Today we are going to solve paper 4.1 of May-June 2022 Physics 0625. This is a 80 mark paper and it's a structured type of question paper. Let's get started. So we have the first question. A car of mass m is traveling along a straight horizontal road at a constant speed v at time t is equal to 0. The driver of the car sees an obstruction in the road ahead of the car and applies the brake. The car does not begin to decelerate at t is equal to 0. Explain what is meant by deceleration. The decrease in velocity per unit time, right? That is deceleration, correct? So next we have state one reason why the car does not begin to decelerate at t is equal to 0, because driver needs some thinking time, right? He will apply the brake, he'll move his leg away from the accelerator, apply the brake. So the driver takes some thinking time, right? Okay, next we have figure 1.1 is the distance time graph. Just a second. Figure 1.1 is a distance time graph for the car from t is equal to 0. State the property of distance time graph that corresponds to speed, right? Distance time graphs, slope or gradient, right, is speed, right? If it was displacement time graph, that would be velocity. Then determine the initial speed v of the car. Now to determine the initial speed, what we can see is that for some time the speed is constant, right? For some time the speed is constant. Let us take a smallest, just a second, let me check this once. Okay, determine the initial speed v of the car. So we'll just have to take the first few seconds, right? So let's say this is from 0 to 1, there are 10 divisions. So 0 0.1, 0 0.2, 0 0.3, 4 and 5, right? That at that point, this much is the velocity. And here 10 divisions are 20. So that's 0 0.2. So 2, 4, 6, 8, 10 and 12, right? So 12 upon 0 0.5, right? 12 upon 0 0.5 will give you 24 meters per second. Your answer is 24 meters per second here. Don't forget to write the units. Okay? Mike Oscar. Okay, so we have next part of the question. When the, just a second, okay. When the car is decelerating, there is a constant resistive force F on the car due to the brakes. The deceleration of the car is greater than F by m and is not constant. So this force changes with its acceleration, right? Explain why the deceleration of the car is greater than F by m due to friction, on tires, right? And drag of the air. Now what happens is when the velocity of the car decreases, the drag of the air decreases, and that's why it is not constant. Okay, why is it not constant? Because the frictional force changes with velocity. The frictional force changes with velocity. Okay, then we have, I think, question number 2. Yes. This figure shows water stored in a reservoir behind a hydroelectric dam. Okay, so there's a reservoir of 150-meter height, generator turbine. State the form of energy stored in water in the reservoir that is used to generate electricity. It will be potential energy because there is height. So you have potential energy. Then let's see what's next. The turbine is 150-meter below the level of water in the reservoir. Atmospheric pressure is 1 into 10 to the power 5 Pascal. The density of water is 1000 kilogram per meter cube. Calculate total pressure. So they want pressure due to liquid and the atmospheric pressure, right? We can find pressure due to liquid by the formula density into height into the gravitational acceleration plus 1.0 into 10 to the power 5. Right here you can use your calculator. Density is given as 1000, the height is 150, g we take as a constant 10, right, plus 1.0 into 10 to the power 5. Now we have 3, 4 and 5 zeros, right? So I can write 10 to the power 5 into 15, right? 15 into 10 to the power 5 plus 1 into 10 to the power 5, that is 16 into 10 to the power 5 pascals, right? That is your answer. Then we have next question. The turbine has a cross-sectional area of 3.5 meters square. What is the force exerted on the turbine by the water? Now we know force is equal to pressure multiplied by area. We just found out that pressure is 16 into 10 to the power 5. Area is given as 3.5, right? So you have 16 into 3.5, which is 56 into 10 to the power 5 Newton, right? Let us also see, did I forget to write the units in the previous answer or not? Let's have a look. No, I have written and Newton here as well, right? Do not forget to write down the units. That will cost you 1 mark. Then we have water flows on the turbine through a pipe of constant cross sectional area. Explain why kinetic energy of water in the pipe remains constant as it flows through the pipe, right? Now what is happening? How much ever water is going in, that much is coming out. So kinetic energy is constant because velocity is constant, right? Because velocity, or you may write speed also, right? This is in a known direction, so velocity is constant as the rate of water going into the pipe, water going into the pipe and out of it is same, right? So how fast it is going in is equal to how fast it is coming out. Therefore the velocity is constant and therefore kinetic energy is half mv square. So kinetic energy is also constant. Then we have third question. During a picnic on a warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Evaporation cools the water in the cloth. Explain in terms of molecule how evaporation cools the water in the cloth. So what happens is particles or water molecules, right? You can write water molecules, particles of water with higher energy can escape, right? They obviously collide with one another, but they can escape from the cloth, leaving behind particles with, right? It leaves behind particles with lower energy, hence lower temperature, reducing a cooling effect. Reducing a cooling effect. Okay. As the water in the cloth cools, so does the lemonade. Explain how electrons transfer thermal energy through the metal of the can. Now, first we need to understand that in this type of question, cold energy does not travel, right? There is nothing like cold energy. What is happening? Lemonade loses energy, right? So what is going to happen here? The particles of lemonade lose energy. Explain how electron transfer thermal energy. Okay, lose energy to the tin can, right? The can is made of tin, which with, sorry, with the help of, with the help of electrons transfer energy by their movement, right? The electrons move by their movement to the damp cloth that is colder due to evaporation, right? So now the damp cloth will get a little bit heated up and it will give rise to more evaporation and in turn more cooling, right? This is what happens. I hope everyone can read my handwriting. If you can't, this is the best I can do, guys. Kindly understand. Okay, a thermocouple is a device that is used as a thermometer. Figure 4.1 shows a beaker that contains molten sulfur at an initial temperature of greater than 400 degree Celsius. So the temperature is greater than 400 degree Celsius. On figure 4.1, sketch and label a diagram of the thermocouple that is used to determine the temperature of the sulfur as it cools down to room temperature. Okay, so they need a thermocouple. How do we draw a thermocouple? So there is a voltmeter that measures the temperature difference between the environment and the hot sulfur, right? But how does it do it? Now, this is not mentioned in our textbook, but this is a Peltier effect situation, right? If there is difference in temperature, the electrons will transfer from higher to lower temperature, giving rise to voltage, right? Because transfer of electrons or movement of electrons is current that happens only when voltage is there. So we can measure the voltage, calibrate it to the temperature, and therefore find out the temperature. So this is a thermocouple. You can mention this as metal A. This is also metal A, right? Because the current must be transferred in the same kind of metal, and this is metal B to complete the circuit, right? The circuit must be closed for electrons to actually pass. So that's that. Describe briefly how the temperature of sulfur in the beaker is reduced, right? I said exactly how would we do it. So the transfer, let's not write transfer, let's say the movement of electrons from hot junction, right, to cold junction produces voltage which can be calibrated to measure temperature, which can be calibrated to measure temperature. Okay. State one advantage of using a thermocouple to measure the temperature rather than using liquid in glass thermometer: higher range, right? As we can already see, it is measuring temperature difference between a 400 degrees Celsius molten sulfur and environment, which is expected to be at 25-30 degrees Celsius, right? So higher range is definitely an answer. Then we have question number 5. Figure 5.1 shows a kitchen tap that supplies instant boiling water. Cold water passes over an electric immersion heater, immersion meaning the heater is immersed inside the water, inside the tap. The boiling point of water is 100 degree. State what is meant by boiling point. The fixed point, right? The fixed point at which water or a liquid changes to gas, a liquid changes to gas at constant temperature, right? Until unless all of the liquid is boiled, if it is a pure substance, then temperature will not change. Immersion heater is powered by the mains at a voltage of 230 volts. When tap is opened, the heater switches on and the current in the heater is 13 ampere. Calculate the thermal energy produced by the heater in 60 seconds. So we already know that power of an electric heater or any electric appliance is I into V. But energy is power into time. So here we can write energy is equal to IV into T, right? That is 13 into 230 into time in seconds, which is 60. So let me calculate that. We have 179,400. So 179,400 joules. But if you observe, there are two significant figures everywhere, right? Maximum there are two significant figures. We cannot have an answer with four significant figures. So I will write this as 180. I think this is enough zeros. Forgot, let me check. 13 into 230 into 60. 179. No, there is one more zero. These many joules, or you can write 180 kilojoules. That is also correct. Then what is the next thing? Specific heat capacity of water is 4200 joules per kg degree Celsius. The cold water that enters the tap is at 22 degree. Calculate the rate at which water at its boiling point emerges from the tap. So the change in temperature is 100 minus 22. It enters at 22 but exists at 100. So we have 100 minus 22 is 78 degree Celsius. right? So this is delta theta. We already have the heat capacity, that is 4200. We already know the heat used, which is 180 into 10 to the power 3 joules. What do we need to find out? Calculate the rate at which, okay, so per second how much of water comes out. So we just need to find out that how much mass of water comes out, but per second, right? So this is the total, oh sorry, total heat, right? Now what I need only power, right? I do not need this, I actually need power. Then I can find the rate. Power is I into V, which is 20 to 30 into 13, right? Rate is measured in kilogram meters per second. So what I can simply do, see, kilogram I can measure because mass I can measure. So if I find out power upon the heat, right, per second, that will give me the mass flow rate. So I'll write it as m dot, right? Just a second. So power is in seconds, right? Okay, yes, this is the correct deduction. I hope you understood. So what do we have? Power is 230 into 13. We have 4200 into 78. So we have 230 into 13 divided by 4200 into 78, right? So I get 9.12. Okay, I'm not writing here, I don't have space, into 10 to the power minus 3 kilogram meters per, I think not meters per second, it should just be kilogram per second, right? Mass flow rate, kg per second, right? So oh, sorry, this is your answer, right? Then we have the next question. The metal tap is earthed and there is a fuse in the cable that connects the heater to the mains. Explain how the earth wire protects the user. Removes any residual charges, right? If there are any static charges or residual charges, so it removes any residual charges on metal tap. Then explain how fuse protects the circuit. It melts if current higher than rated capacity is passed to open the circuit, right? What does it do? It melts and opens the circuit. To open the circuit, right? Next, let's see what do we have. Okay, I think this question is over. Yes, it is. Then we have question 6. 6.1 shows a road next to the sea. Okay, this is the sea, this is the road. On a sunny day, sun warms the road. Then what happens? Describe how energy from the sun reaches the earth and warms the road. So there are 3 components. Describe, right? You have to explain how it transfers from the sun to the earth and then it warms the road. So what happens is infrared radiation, okay, I'll call them radiation only, they are EM waves, come from the sun. So it's radiation, I don't need to write there is radiation taking place, but if you write infrared waves, you have to write radiation takes place from the sun to the earth, heats up the road heats up the road due to, road is made of asphalt, right? Due to vibration, and it's solid, right? Asphalt is solid. Vibration in its molecules, right? So the neighboring molecules will also get heated up. A part of the road that is not exposed to the sun will also be heated to an extent because of this, right? Then we have the temperature of the road is greater than the temperature of the sea. The surface of the road is black. Suggest one reason why temperature of road is greater than the temperature of sea. Because black surfaces are a very good absorber of radiation. Black surfaces are good absorber of radiation. The air above the road is heated by warm road. Describe how this affects the molecule of the air. So when the molecules of the air get heated, they expand and rise up. The molecules of the air expand and rise up because now their density is lesser than cold air, which would naturally sink down. A cyclist traveling along the road notices that a cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. You may include a diagram if it helps your answer. Yes, this is sea breeze, right? How does it happen? So this is my diagram. Let's say this is land and this is sea. Okay, land is hot, so the air rises up. Air rises. Okay, sea, that is cold, comparatively colder, right? Air, cold air replaces, right? Cold air replaces the hot air. Explain how convection produces this breeze. So due to convection, the hot particles move away. Hot particles move away to be replaced by cold, colder air above the sea. Right? So that's your answer. Then let's see what's next. Okay, that question is over. We have question number 7. Figure 7.1 is a full scale diagram of small nail n in front of a thin converging lens. The line L represents the lens. Okay, the focal length of lens is 3 centimeter and they have given to us that this is 1 centimeter and this is also 1 centimeter. Let's see what else. Rays of light parallel to xy, right, which is the principal axis, right, are traveling towards the lens. Describe what happens to the light after it passes the lens. All the light converges, right, because this is a converging lens. Sorry, I wrote converging lens. It converges to a fixed point on the right hand side of the lens. Okay, next. On figure 7.1, mark and label with an F each of the two principal focuses. The principal focuses are 3 centimeter apart, correct? So I'll need my scale here. I'll need to actually have some perspective, because right now this is not 1 centimeter. Okay, it's already given that 1, 2, 3, 4, 5 and 6 units. I think, let me check once more. 1, 2, 3, 4 and 5. Okay, so 5 box is 1 centimeter. So from the center I have 1, 2, 3, 4 and sorry, this is taking longer than I thought, guys. Okay, so let me have a pen. 1, 2, 3, 4 and 5. So this is 1 centimeter, more 5 units, 1, 2, 3. So this should be 5, 10 and 15. So it should be this, right? This should be the first focus F, and in the same way I'll just estimate it. What you have to do, count 15 boxes from here and from here, right? So this much, and I think should be the same. 1, 2, 3, sorry, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. I think it should be here. This is the other focus. Let's see what is the next part of the question, right? You can always use your ruler, you can always use your pencil. Then the small nail of height 1.2 centimeter is positioned 2 centimeter left of the lens, which means it is nearer to the lens compared to the focus. By drawing on figure 7.1, find the position of the image of N and add image I to the diagram. So let's again take out our scale, right, ruler. So what do we need to do? First we need a ray passing from the center of the lens and the tip of the nail. I think this will do, right? So let's draw a line like this. Okay, also let's give it an arrow. It's going in this direction. I've extended on both sides so that if we need to trace it back, we don't need to draw the line again, right? The second line must be parallel to the principal axis, right? And must extend till focus as it is, sorry, not till focus, just a second, guys, sorry. Yes, so it must extend till the lens, right, parallel. Once it passes the lens, this ray must be passing through focus. So let's make it pass through focus, right? And what I'll do again, I'll again trace it back here. Now as you can see, these two rays are never going to meet on the right hand side, so the image is never real, but these can actually meet on this side, right? So I'll just make sure, like, I'll draw dotted lines. Okay, I'm just showing you that these lines need not to be solid. These lines have to be dotted, this much extension of both lines. What you do is, next you find out where these two lines meet and then draw the image here, right? This is your image I. Okay, this is your image I, and that is our answer. Then state and explain whether I is real or a virtual image. So state, what is it? Virtual. And explain. How do we explain? The rays never actually meet, or just never meet, because for a real image the rays must actually meet. State the name given to a lens when it is used in this way. This is a magnifying glass, right? So magnifying glass. Okay, next, let's see, we have question number 8. Figure 8.1 shows two vertical cylindrical tubes and cylindrical magnet all held in a vacuum. So there is no air friction. One tube is made of plastic, the other tube is made of copper. The two cylindrical tubes have identical dimensions. Okay. The magnetic field, the magnetic field of a small cylindrical magnet is extremely strong. Initially, the magnet is at rest at the top of the plastic tube. The magnet is released and it falls through the plastic tube without experiencing a resistive force. Magnet takes 0.67 seconds to fall to the lower end of plastic tube. The mass of the magnet is 0.012 kilogram. Calculate the kinetic energy of magnet when it reaches the lower end of the plastic tube. Okay, long question. So we have kinetic energy is equal to half mv square. Half, you don't need any values. Mass is already given 0.012 kilogram, and you can find the velocity. Now if it was at rest, then we know from the equation of motion velocity is equal to u plus gt, right? But it was initially at rest, so this is already 0. So you just need g, which is 10, into time t. It takes 0.67 seconds to fall, right? So this will easily give you the kinetic energy. So it will be 0.012 into 10 into 0.67, whole thing divided by 2. So you have 0.0402 joules, or I can write 400 millijoules. Okay, 4 into 10 to the power, not 4, I must write 400 into 10 to the power minus 3 joules. Okay, that is your answer here. Then we have the magnet is then held at the top of the copper tube and released. As it falls through the copper tube, an electric current is generated in the copper. Explain why there is a current in the copper. The magnetic field lines, what is happening? The magnetic field lines are changing, which gives rise to a current. The magnetic field the magnetic field lines are changing, right? Or you can say magnetic flux is changing inside copper tube, giving rise to a current. Okay, now next question. The current in copper produces a magnetic field of its own in the tube. The magnet falls much more slowly in the copper tube than the plastic tube. Explain why magnet falls more slowly in the copper tube. The magnetic field of copper tube, the magnetic field of copper tube opposes the fall of magnet, right? They are in opposite direction. Both the magnetic fields are in opposite direction, so they repel. So I'll write repel each other. Okay, let's just mention that, repel each other. Then let's see what's next. We have, okay, question number 9. Combinations of logic gates are used when digital signals are processed. Describe the difference between a digital signal and an analog signal. You may include a diagram if it helps your answer. So okay, so we have analog signal, right? So I will write voltage versus time, and I will mention this is analog signal. Okay, am I spelling it correct? No, I am not. We have GUE, and then we have digital signal, right? So true or false, right? Nothing else. So we have voltage and time. What is this? This is a digital signal. What is the difference? Digital signal has only two values. Digital signal has only two values, right? The output input has only two values, 0 or 1, true or false. Then we have figure 9.1. The 9.1 is a truth table for logic gate X. State the name of the logic gate X and draw the symbol that it represents. Now let's see. So 0, 0 gives 1. Now the two logic gates that we know of are or AND gate, right? So 0 plus 0 is 0. 0 multiplied by 0 is also 0. So here your output is 1. Therefore, it is either a NAND gate or a NOR gate. Okay, it's not or AND gate. So let's check here. If it was a NAND gate, right? 0 and 1 gives 0. Here it's already 0, so it is not a NAND gate. What is it? It's a NOR gate. How does a NOR gate look like? These are the two input. It looks like an arrow, and this is the output with a dot in front to show that this is NOR gate. Okay, then we have logic gate Y is identical to logic gate X. Draw a combination of X and Y that behaves like an OR gate. Label the inputs A and B and label the output Q. Now what we can do is, guys, if you just combine the OR gate twice, it gives the, sorry, if you combine the NOR gate twice, it gives the OR gate output. So this here, right, and this dividing into two inputs again, the same thing happening over here, and this is your output. Then A and B should be your input. This is A, this is B, this is not your input, right? That is your input, and Q is your output, which is our answer, right? Now as far as I understand, or what I have read with the syllabus, 2022 October November is going to be the last paper that asks these gate and boolean questions. From Feb March 2023, these questions are not in syllabus. Next, two of the isotopes of hydrogen are hydrogen 2 and hydrogen 3. State one similarity in composition of their nuclei. Each has one proton, right? Each has one proton. Okay, next, describe how a nucleus of hydrogen 3 differs from nucleus of hydrogen 2. Hydrogen 3 contains two neutrons, right? Hydrogen 3 has two neutrons, and hydrogen 2 has only one, right? In a nuclear fusion reactor, a nucleus of hydrogen 2 fuses with the nucleus of hydrogen 3 at an extremely high temperature. This fusion reaction produces an isotope of element X and releases a neutron. Explain why an extremely high temperature is needed when forcing these two nuclei together. Now, what is the charge of the nucleus, guys? The charge on the nucleus is positive. So to overcome this repulsion, you require a lot of energy. That energy comes from heat energy. To bring two same charged particles near a lot of energy is required, which is gained. A lot of high force is required, which is energy, which is gained from heat energy, right? And that is why high temperature is required. Let's write that down. Hence, high temperature required. Okay. Then they have given us some more information. So it produces element X and releases a neutron. Let's see. Using nuclide notation, complete the equation for this reaction. So we have a neutron, right? Neutron has a mass of 1 and a charge of 0, right? 3 plus 2 is 5, 1 is already taken. So here you have 4 nucleons left, out of which 2 are protons. This is actually helium nucleus, or we can say alpha particle. So let's write that only. This is alpha particle, with which we have finished our paper. I hope you like the answers. I hope you understand the answers. Thank you for watching. Come back for more videos. Bye bye.